Now sine inverse 2x. Right, we know that for any general sine inverse u, the for any general function sine inverse u varies from -1 to 1. Now in place of u, just plug in 2x. So 2x will vary from -1 to 1. Now divide everything by 2. So we'll get negative half x till half. So negative half to half is the domain, so which is option number C. Second part, cosine inverse x minus 1. Now we know that for any general cosine inverse u, the u varies from -1 to +1. Now we'll replace u with x minus 1. Now adding 1 on both the sides, so we'll get -1 plus 1, that is 0. X is less than 2. So the x will vary from 0 to 2, which is our domain. So that is option number B. Now we know that for any general tan inverse u function, u varies from -infinity to +infinity. Now we'll replace uh, u with x square. So x square will vary from -infinity to +infinity. Now we know that x square is always a positive number. So there's no point in comparing with writing -infinity. So in place of -infinity, we can write 0. So it will vary from 0 to infinity. Now when you root in this function, so you'll again get x square is less than negative, so that means it will vary from -infinity to +infinity. So the domain will remain unchanged. It will be same from -infinity to +infinity. Now the last part, the domain of sine inverse x and tan inverse x. Now for sine inverse x, we know that it's -1 to 1, and for tan inverse x, it is all real numbers. Now you have to find the region which is common to both of them. We can draw a number line here from -infinity to +infinity, mark the critical points. So sine inverse x is valid from -1 to 1, and tan inverse is valid for all real numbers. So the common is only this region, -1 to 1. The domain would be -1 to 1, close bracket. So option number B.